Ever wondered how our brain processes information and learns over time? It's a fascinating process, isn't it? Now, imagine a technology that imitates this very process. That's exactly what artificial neural networks achieve. They are a system of algorithms that interpret sensory data, kind of like how our brain perceives the world around us. These networks are crafted in a way to replicate our brain's phenomenal ability to learn from experiences. From powering the recommendation engine of your favorite streaming service to enabling self-driving cars, artificial neural networks have truly revolutionized the tech world. They have made machines smarter, more intuitive, and surprisingly human-like in their responses. One such fascinating subset of artificial neural networks are the adaptive resonance theory models, namely ART1 and ART2. But what exactly are these models? Well, let's dive in and find out in the next segment. Imagine a model that could handle binary input patterns. That's what ART1 does. ART1, short for Adaptive Resonance Theory 1, is a type of artificial neural network that specializes in dealing with binary input patterns. These patterns, made up of ones and zeros, are the fundamental language of computers, the DNA of digital information, if you will. In the world of artificial neural networks, binary input patterns are the simplest form of data that can be processed, and ART1 is a master at processing this kind of data. The ART1 model is composed of two layers, an input layer and a competitive layer. The input layer receives the binary patterns, while the competitive layer is where the magic happens. Here, the neurons compete to be activated by the input pattern, with the one most closely matching the pattern winning the competition. This competition is a key feature of ART1's architecture, and it's what allows the model to adapt and learn from the input patterns it processes. Each layer in the ART1 model has a specific role. The input layer, as the name implies, is responsible for receiving the input data. It's the gateway through which the binary patterns enter the model. On the other hand, the competitive layer is responsible for processing the data and making sense of it. It's like the brain of the model, interpreting the binary patterns and learning from them. The beauty of the ART1 model lies in its simplicity and versatility. With just two layers, it can process complex binary patterns and adapt to new information. It's like a sponge, constantly soaking up data and learning from it. And the best part, it never forgets. Once a pattern is learned, it's stored in the model's memory, ready to be recalled when a similar pattern is encountered in the future. So that's ART1 for you, a model that deals with binary inputs and has a unique learning method. It's a testament to the power of artificial neural networks and their ability to mimic the learning processes of the human brain. Now, what if we could process continuous valued input patterns? That's where ART2 comes in. Imagine a scenario where the data you're dealing with isn't just binary. Instead, it's a continuous stream of information, a blend of values that don't simply fit into the 1 or 0 categories. This is where Adaptive Resonance Theory 2, or RT2, steps onto the scene. ART2, like its predecessor ART1, is a model within the realm of artificial neural networks. But while ART1 was designed to process binary input patterns, ART2 takes it up a notch and is equipped to handle continuous valued inputs. This makes ART2 a more versatile tool, capable of dealing with a more extensive range of data types. So how does RT2 manage this? The answer lies in its architecture. RT2 is composed of multiple layers, each with its unique purpose and significance. The input layer, for instance, is where the continuous valued data enters the network. This layer interacts with the comparison layer, where the initial pattern comparison happens. Next comes the recognition layer, which is where things get really interesting. In this layer, the network decides if the input data matches an already known pattern, or if it's something new that the network needs to learn. This decision-making process is what sets ART2 apart from other models. The final layer, the reset layer, acts as a sort of quality control for the network. If the pattern isn't a good match, the reset layer sends a signal to reset the process and search for a better match. This is an essential part of ART2's ability to adapt and learn from new data. In a nutshell, RT2 is a dynamic, adaptable model that can handle a variety of data types. Its multi-layered architecture allows it to process continuous valued inputs, compare them to known patterns, and adapt to new information. That's ART2, a step up from ART1, capable of handling continuous valued inputs. Though ART1 and ART2 might seem similar, they have some key differences. Let's dive into these. First, let's talk about the kind of input data they handle. Art1 is designed to work with binary input patterns. Think of it as an on-off switch. It's either 1 or 0. On the other hand, RT2 can handle continuous input patterns, giving it a broader range of application. It's more like a dimmer switch with varying degrees of intensity. The architecture of these models also differs. Art1 has a simpler structure, making it faster and more efficient for binary data. It's like a sleek sports car, designed for speed and performance on a well-paved road. Art2, however, has a more complex structure, which allows it to handle the intricacies of continuous data. Think of it as an all-terrain vehicle, built to navigate through challenging landscapes. Now, where would each model be more suitable? Art1, with its binary input handling and streamlined structure, is great for tasks that require speed and efficiency. Art2, with its ability to handle continuous inputs and its robust architecture, is well suited for tasks that require a more nuanced approach, dealing with complex real-world data. Choosing between Art1 and Art2 depends on the type of input data and the specific requirements of the task at hand. So, what have we learned about art models? Quite a bit, actually. We've journeyed together through the complexities of artificial neural networks and dived deep into the specifics of Art1 and Art2 models. Both of these are fascinating adaptive resonance theories, each with its unique characteristics and use cases. Let's take a moment to revisit Art1. It's a binary system dealing with binary input patterns. This model is designed to categorize input patterns into various classes based on their similarities. Quite nifty, isn't it? Its application is found in areas where pattern recognition is crucial. Moving on to RT2, it's a bit more advanced. It can handle continuous input patterns, giving it a broader range of applicability. It's like Art1's big sibling, expanded and evolved. This model is particularly useful in fields like image processing and voice recognition, where continuous data streams are the norm. So, how do they differ? Well, the key difference lies in the type of data they handle. While Art1 is perfect for binary data, Art2 steps in when the data is continuous. It's a bit like choosing the right tool for the job, isn't it? Remember, understanding these models is a step towards harnessing the power of artificial neural networks. But don't stop here. The world of artificial intelligence is vast and constantly evolving. Keep exploring, keep learning,